Okay, so for this problem, we're asked to estimate the amount of positive charges in the human body. And so for that, and we need to also know that the human body is made mostly of water. We can say that the total mass of a human is, for estimation purposes, is around 75 kilograms. And basically the idea is that water molecule is going to have a certain amount of charges. So then how many water molecules in our human is basically what we need to figure out. And for that, we need to know kind of the molar mass of water. And I do not know the symbol for molar mass that's typically used. So I'm just going to write molar mass equals 0.018 excuse me. So it's 18 grams per mole, and then I'm going to convert that to kilograms per mole. So kilograms per mole. So to do this problem, I'm going to talk it through, and I'm not going to use symbols like I usually would, because this one's just kind of like a big long unit conversion. So we start off with 0.018 kilograms per mole. And so we want to know how many particles there are, and so or how many molecules there are. And so there's Avogadro number molecules in 1 mole, so that's 6.0. I'm just going to use a significant figure. Even though everybody remembers it's 6.022 times 10 to the 23, for some reason that's a more memorable number, in my opinion. I don't know, do you think it's a more memorable number? And that's going to be an X, and I will make it look like a real X. Give it all the glory of an X. Okay, 6 times 10 to the 23 molecules per mole. Wow. Kind of confusing. Or, oh. Hold on. So I need to do, oh yeah, I need to divide by that. Let me go back a little bit. Yeah, so I need to get the units right. So then that's 6.022. All right, I used it. Rolled off the tongue too easily, and I already started writing it. Times 10 to the 23 molecules per mole. Great. So now we can basically, and then we can, I guess there's a few different ways we could do it. When I originally did this problem, I kind of stopped here and inverted the fraction and said, okay, look, let's get the number of molecules per kilogram and continue. So we can kind of invert this fraction and say there's 6 times 10 to the 23 molecules per kilogram. Of the human. And then we can say, okay, well, how many kilograms are there? There's 75 kilograms. So now, canceling out the units of kilograms, we're left with the number of molecules, and then we need the number of charges per molecule. So an oxygen molecule has a water molecule is 2 hydrogens and 1 oxygen. The oxygen has protons in the nucleus, and the 2 hydrogens are each 1 proton, and so that's a total of 10 protons. So 10 charges per molecule. And then you have to ask how many coulombs there are in 1 charge, and so the elementary unit of charge, 1.6 times 10 to the minus 19 coulombs per charge. So 1.6 times 10 to the minus 19 coulombs per charge. And as I was scanning this, I realized I forgot to put the 0.018 here. Sorry about that. And so I'm going to cancel out this molecule unit, cancel out this charge unit. So now we're basically just left with coulombs, which is what we wanted. When I plugged this whole thing into a calculator, what I got was 4 × 10 to the 9 coulombs. Oops. 4 × 10 to the 9 coulombs.